Now, if we're asked to multiply radical expressions, we can always do that because the rule for multiplying them is they will directly multiply every time. So it's actually a little bit harder than adding because adding just doesn't work unless it's the same. But with multiplying, they should always work. Like say I wanted to multiply 6 times root 3, that's just root 18. But notice that after I multiply them, sometimes it could be simplified after the fact. Like 18 is 9 times 2, so this would make 3 root 2. And that's the general idea of multiplying. You want to first combine them together and always check to see if something can be simplified. And also, sometimes we might want to multiply into a combination of different things, like say I had root 5 times root 3 minus root 2. Well, all algebraic properties still hold for these sorts of expressions, because you can kind of think about it as, well, root 5 is some weird number, so are root 3 and root 2. I could type those into a calculator, but that's defeating the purpose of all of this stuff. But I could use the property of algebra where I can distribute the root 5 into both of those terms. So this would be root 5 times root 3 minus root 5 times root 2. And so that would leave me with root 15 minus root 10. And in this case, that's just how I would leave my answer, since that will not, neither one of those will simplify any further. So, looking at a few more examples, like say number 11, and again, the index would have to match for this to work, we could multiply all these together by distributive property. Root 4 will multiply on each of those. Sorry, cube root. And so basically the 2 would be out front still, and then cube root of 4 times 5 would give me the cube root of 20. Then in the last one, I'd have the cube root of 4 times the cube root of 2, which would be the cube root of 8. And actually, cube root of 8 is just 2, so I could even consider simplifying them if possible. And in this case, this will not simplify any further because 20 was comprised of 4 and 5. Neither one of those is a perfect cube. But note that the index is important, right? Because if this was a square root, this would simplify, but since it's a cube root, it won't. And also, if we had an example such as this one, you would need to make sure to FOIL out completely. And actually, the inner products will always simplify when FOILing. So, of course, if I have 2 terms times 2 terms, we need to make sure to have 4 total products. So we'd have minus 2. Also, the solid number will multiply into the outside because, the root is sort of like, I kind of treat that as x. 2 times 5 is 10, so this would make 10 root 7. Then moving on to the third one, I'd have 3 times negative 1 is negative 3 root 7. And then 3 root 7 times 5 root 7. Also, with these sorts of combinations, I like to multiply the non-radicals together because 3 times 5 is just 15. I know that. And root 7 times root 7, well, technically that's root 49, but whenever you're multiplying a root times itself, that would constitute square root of 7 squared. And squaring a root always cancels because of cancellation property. But, I could write that as root 49 just by following along with the general trait of multiplication. Because root 7 times root 7, the inside will combine. And the roots will play together, the ones outside the roots will play together. Otherwise, it works a lot like multiplying with x's. And now I could combine like terms because, again, as I said before, root 49 is just 7. So this would be 15 times 7. 15 times 7 is 105. And then I have a minus 2, so that would make 103. And then the roots will play nicely because those won't simplify, but 10 root 7 minus 3 root 7 will just make 7 root 7. And that would be my final answer. And remember, again, these would not combine because roots, this is like x. This does not have root 7. These are not like terms. They're not like radicals. So like these two ones add together because those two result in regular whole numbers, rational numbers. Whereas the other two are irrational. Those will be in their own little club. And if you had to square something, remember that squaring must, to evaluate such a thing, you can't just square each term by term because basic tenets of algebra is squaring means multiplying by itself. So this would mean root 2 plus 3 times root 2 plus 3. And I would need to FOIL. So foiling this out would leave me with root 2 times root 2 is 2 plus 3 root 2 plus another 3 root 2. 3 times 3 is 9. But basically this would leave me with 11 plus 6 root 2. And it's sort of like It works a little differently than polynomials because I could end up combining the root component, which will simplify. And actually, the very last one for this video that I wanted to mention is what happens if you multiply a difference of squares situation involving roots. And it's kind of playing back into, if you remember, like say I had x squared minus 4, that will always factor as x plus 2 times x minus 2 because those numbers are a difference of squares. Well, with roots, when you're multiplying these things, sometimes we refer to these as conjugates because it's one is something plus something, the other is something minus something. You'll see that it creates a very valuable expression when it comes to radicals. And actually what will happen is it will rationalize it. And let's go ahead and just multiply it out. So here we would need to FOIL. So that would give us 8 times 8 is 64. 8 times root 3 is plus 8 root 3. Negative 3 times 8 is negative 8 root 3. And then negative root 3 times positive root 3 is negative root 9. And since we're multiplying conjugates together, as we said with difference of squares, the inner product will always cancel, and it will just leave me with the first thing squared, 8 squared, minus the second thing squared. It's kind of like x squared minus y squared, a difference of 2 squares. And since a radical squared cancels, this will leave me with 64 minus 3, or 61. And this is kind of the whole deal with conjugates in radicals. This is why it's an important thing to recognize. When you multiply by the conjugate, it will rationalize it. It will become a real rational number. It will no longer be irrational.